Hey guys, so today we're going to start our unit on oblique triangles, which is looking at triangles that don't have any right angles. So before we get started with that, let's do a warm-up on how to find the length of missing sides or angles in a right triangle. So on the left side, we've got a right triangle, and we have an angle that is 33 degrees, and we've got the length of a side, which is 8.7, that is the adjacent side to that angle, and then we are looking for x, which happens to be the hypotenuse. So to find the missing side of a right triangle, we can use our SOHCAHTOA. And since we have an angle and the adjacent side and the hypotenuse, we're going to use cosine. So let's set up the problem as the cosine of 33 degrees, this is in degrees, is equal to adjacent, which is 8.7, over hypotenuse, which is x. Okay, and then to solve for x, we're going to multiply both sides by x to get rid of the fraction. So x times the cosine of 33 degrees, is equal to 8.7, and then we can divide both sides by the cosine of 33 degrees. To isolate that x by itself. So in my calculator, I'm going to type in 8.7 divided by the cosine of 33 degrees. And that should give me x as, if I round to the nearest tenth, that would be 10.4. Okay. And so we know that we can use SOHCAHTOA to help us find a missing side of a right triangle or a missing angle. But what if we don't have a right triangle? So if we look at the example on the right side, we got a triangle here where we have the measure one angle as 35, the measure of the other angle as 105, and then the measure of angle A we don't know, but we can figure it out because the sum of the interior angles of a triangle is 180. Now if we were to find C, I can no longer use SOHCAHTOA anymore. So to solve this problem, we're going to have to use a new rule, something called the law of sines. So can't use SOHCAHTOA because it's not a right triangle. So this unit, we're going to focus on solving non-right triangles, something called oblique triangles. So we use the law of sines when we're solving oblique triangles, and oblique triangles are triangles that don't have any right angles. And what the law of sines essentially says is that the ratio, so ratio is a comparison of two numbers, the ratio between the length of one side of a oblique triangle and the sine of the angle opposite that side is going to be the same for all of the sides and all of its opposite angles in that oblique triangle. And we can set up any of the ratios used in the law of sines to set up a proportion to solve for any variables as long as we have a match set. So the law of sines says A, so we've got triangle ABC, and we label the side opposite angle A little a, the side opposite angle B little b, and the side opposite angle C little c. So A divided by the sine of angle A is always going to be equal to B divided by the sine of angle B, and that's also equal to C divided by the sine of angle C. And depending on what information we're given, we can use any two ratios, set them equal to each other, and then cross multiply to solve. So we can use these two, or we could use these two to set up a proportion. So let's take a look at an example. In triangle ABC, we want to solve for side A, given that angle A is 65 degrees, angle B is 45 degrees, and the length of side B is 10 inches. So let's draw a picture. Let's draw a diagram. And I'm just going to draw any triangle not drawn to scale. And I'm going to label it ABC. Okay, so angle A is 65 degrees, angle B is 45 degrees, and I know that the side opposite angle B, little b, is 10 inches, and that's all I know. So I am looking for little a, which is this side right here. And to solve this problem, can't use SOHCAHTOA because we don't have a right triangle. We're going to use law of sines. And remember, in order to use law of sines, we need a match set. That means I need to know one angle and the length of its opposite side. This is our match set. That tells me I can use the law of sines. So I'm going to go ahead and use that. So 10, which is the length of that side, over the sine of 45 degrees, that's my match set, is going to be equal to, and I'm looking for a, so I'm going to use a, over the sine of 65 degrees, which is the angle opposite a. And once I have that set up, then I can go ahead and cross multiply. And when you cross multiply, it doesn't really matter which one you multiply first. So I'm just going to start with a. A times the sine of 45 degrees is equal to 10 times the sine of 65 degrees. And then to solve for a, I can just divide by the sine of 45 degrees. Now, when you put this into your calculator, you want to be careful and make sure you put the parentheses in to close the parentheses for the sine of 65 before you divide. Otherwise, it's going to give you an incorrect answer. So in my calculator, type in 10 times the sine of 65 degrees, close your parentheses, and then divide by the sine of 45 degrees, close your parentheses. And we should get a as roughly 12.8 inches if we round to the nearest 10. Just make sure that you have your calculator in degree mode here since we're working with degrees. Let's look at another example. Very similar, we've got a triangle ABC, so let's draw that out and label what we're given. And it doesn't matter which vertex you label A, B, and C. So little a is 14 inches. Little c, the side opposite angle C, is 8 inches. And angle A is 75 degrees. And here we are looking for angle C, this angle right here. Okay, so again, we're going to set it up by starting with our match set. So we have a match set here. We have 75 degrees and the opposite side of that angle, which is 14 inches. So let's start with that. 14 over the sine of 75 degrees, set up a proportion, is equal to, and we're looking for angle C, so let's start with the side opposite angle C, so 8 over the sine of angle C. And you could name it theta if you want to, you could name it C. And once we have this proportion set up, we're going to cross multiply. So we have 14 times the sine of C is equal to 8 times the sine of 75 degrees. Okay, and then to solve for angle C, we're going to start by dividing both sides by 14. And we've got the sine of angle C is equal to 8 times the sine of 75, make sure you close your parentheses, and then all over 14. And then finally, to get this angle by itself, if I want to undo that sine, we're going to take the sine inverse of both sides, just like what we would do when we have a right triangle and we're looking for an angle. Take the sine inverse, which cancels out the sine, and so the measure of angle C is equal to the sine inverse of all of this, 8 sine of 75 all over 14. Now, if you want to do this calculation out first, that's okay. And then in your calculator, you can just type in sine inverse, and then in parentheses, second answer, and you put in your previous answer from your calculator, and you don't have to do any rounding. So I would try to avoid having to round in the middle if you can, because then your calculations, your final answer will be slightly off. So avoid rounding in the middle if you can help it. And that's going to give me about 33.5 degrees. Okay, last example. An application problem. So you've got a pole that tilts toward the sun at 8 degrees angle from the vertical. So instead of standing vertically up, your pole is slightly slanted at an angle of 8 degrees from the direct vertical. And it casts a 22-foot shadow on the ground. So you can see that's the shadow. And then this is the angle right here from being tilted. The angle of elevation from the top of the shadow from the tip of the shadow to the top of the pole is 43 degrees. So here's the tip of the shadow to the top of the pole, and that forms an angle of 43 degrees, and we want to figure out how tall the pole is. So the diagram is drawn for you, and if you want, you could redraw it and relabel it so you can see it a little bit better. So I know that I have A, B, C, and the information that I'm given is that angle A is 43 degrees. I'm looking for little a, that's the height of that pole, and this angle right here is 90 degrees plus that 8 degrees, so that's 98 degrees. And I know that the distance between A and B is 22 feet, and that's all I know. So if I'm looking for little a, again, I can't use SOHCAHTOA, so I need law of sines, and in order to use law of sines, I need a match set. In this case, I don't see a match set right away, but we can find the measure of angle C because I know the measure of angle A and B. So 180 minus 98 minus 43, that's going to give me 39 degrees. That is the measure of angle C, 39 degrees, and now we have our match set that we need to use law of sines. 39 degrees, and the length of its opposite side, 22 feet. So let's start with that. 22 over the sine of 39 degrees is equal to A, which is what we're looking for, over the sine of 43 degrees. And now we can cross multiply. So I'm going to move it down here. A times the sine of 39 degrees is equal to 22 times the sine of 43 degrees. And I'm going to divide both sides by the sine of 39 degrees to get A by itself. And that gives us A as roughly, if I round to the nearest hundred, that would be 23.84 feet. And the instructions on practice problems will tell you how they want you to round. And if I ask you to solve the whole triangle, then that would mean to find any missing side and angle. So the only thing left if I want to solve this whole triangle is to solve for the length of side B, and we can just use a different proportion to do that. So as you do the practice problems, if it's an oblique triangle, you know that you can use law of sines. to solve for missing sides and missing angles. And note that the law of sines actually works for any type of triangle, regardless of whether it's oblique or not oblique. So law of sines actually works for right triangles as well. So when you solve a right triangle, if you want, instead of using SOHCAHTOA, you could also use law of sines. But SOHCAHTOA might be a little bit quicker when you have a right triangle.